Okay, so again, still on page 32 of the notes now, looking at implicit differentiation. One of the nice things about implicit differentiation is, let's say you've got a function that you can't exactly solve in terms of y. But the nice thing is that we can still find the derivative of this function. Even though I should stop using the word function. It might not be a function. So we can still find the derivative of this thing. So even though we can't explicitly solve for y, now you might try here, but it's not something we necessarily have to tackle. So okay, let's see if we can find y prime here. What do we do? Well, notice this one, right? And this one, that looks terrible. Notice this one and this one. They're two separate terms, right, separated by the plus sign. If I take the derivative of this side with respect to x, notice we could write it as a function, right, times a function, right, f times g. So the x squared could be f, g could be y. What's its derivative? Well, it's a product, so we'd need the product rule. Okay, what's f prime then? What's x squared? That just becomes a 2x times y, right, plus now the derivative of y, well that's just y prime, or dy dx, whichever one you'd like to write. I'll just write y prime to save us some time, times the original f function, x squared. Now we've also got to take the derivative of this one, so now we've got a y squared times x, right? So, okay, y squared, its derivative would be a 2 times y, but chain rule, we're taking the derivative with respect to x, so we also get a y prime. So now that was our f function. Here's our g function, right? So we got f prime times g plus now f times g prime, right? So y squared times the derivative of x with respect to x, that's just a 1. What's over on the other side, right? The derivative of negative 2 with respect to x, that's just 0. Okay. Now, notice we've got a few terms here. Let's simplify this. Let's make it look a little bit nicer. So you've got 2xy plus x squared times y prime plus 2xy times y prime. Notice the y and the y prime are not the same term, right? Plus y squared. Now, that's equal to 0. Now, what we should be thinking of is how to arrange these so that we can solve for y prime, right? Notice these guys and those ones, right? These guys both share y values, or I should say these ones don't have a y prime and these ones do. So I could move both of these to the right side. Let's do that. Let's do that first. So I've got x squared times y prime plus 2xy times y prime equals, and now that guy over on the other side, right, we just subtract it, we get a negative y squared and a negative 2xy. So now, okay, seems like we're closer to getting y prime on its own. How do I get y prime by itself? These two terms have a y prime multiplied by these terms. So to get them out of here, I have to factor them. So I've got to factor the y prime from each one of these terms. And now it seems we're only one step away from solving for y prime. And please don't try to reduce these, right? It has to be in both terms. You can't reduce the 2xy's. I see that too often. Just a reminder. Okay, there we go. There's our derivative. And it's all in terms of x and y. So to find the slope at this specific position, right, we could just plug it in. Y prime is now a function of x and y. So y prime is at -1, -1, right, at this point, right, this is saying plug in x and y to your derivative y prime. So plugging in that xy value in for our function y prime, we get y prime is equal to, right, negative of negative 1 squared minus 2 times negative 1 times negative 1 all over negative 1 squared plus a 2 times negative 1 times negative 1. So then y prime is equal to, here we got 3 negatives, so we got negative 1, 3 negatives, negative 2 over 1 plus 2, that's a 3. So that gives us negative 3 over 3, so the slope is negative 1 at this point. Okay, let's keep that in mind. Right, so at this xy point, we have this slope. Now, what about, right, y prime at positive 2, negative 1. Right, y prime is equal to, if I plug in the positive 2 here, we got negative 1 squared minus 2 times negative 1 times 2, all over I put those in the wrong order. You guys get the idea. 2 squared plus 2 times x times y. We get a slope of negative 1 plus 4 over 4 minus 4. Ooh. We get negative 5 over 0, right? Undefined. Why did that occur? All right, let's go check out these points. So if you guys have access to the computer, right, you would then, if you go into 3D GeoGebra, right, if you type in this GeoGebra 3D, you'll have an option to, this website then has the option to graph 3D functions. I wanted this one not because it's three-dimensional, but it's not easy to graph for most things. So like Wolfram is okay, but it's got some limits. It won't let you, without buying the software, you can't move stuff around. So here you can go and just type in the equation. Notice I've got it typed in up here. Right, x squared times y plus y squared times x equals negative 2. Now, what was our point? Our point was at negative 1, negative 1. So now, where's that function? Ooh, it's looking in. So notice it's a three-dimensional picture, and it allows me to move it around a little bit. So negative 1, right? Negative 1 in the x, negative 1 in the y, puts us right here. What's our slope? Looks like it's roughly negative 1. Ah, okay, very cool. Now, what was the slope? Right, we had a point of x was positive 2, y was negative 1. Notice what happened here. Right, that gave us an undefined slope. In other words, it was approaching some sort of vertical asymptote. Do you guys now, right, see that at point 2, negative 1, we get a vertical asymptote? Where do you think, what do you think the slope would be here? It's horizontal, right? Slope should be 0. What point is that? Let's see. X is negative 1, y is 2, right? If we just go back to our original, if you just switch the order of some of these, right? If x is negative 1, y is 2, basically we'll end up with a of 4 minus 4 upstairs instead of in the denominator, this becomes 0 over negative 5, and then we'll see that our slope should be 0 at that point. So you guys can try that, right? Try that over on your own. Try plugging in negative 1, 2 into your derivative function and see what it kicks out. Right, we get a negative 4 plus 4 over whatever this simplifies to.